Hi, my name is Madison Card, and my study, Dancing Cognition, investigates differences in trained dancers' proprioception using a modified trail-making test. To provide some context about what inspired this project, I was a dancer for almost 2 decades, a quarter of which I spent professionally dancing. When I began designing Dancing Cognition, I found that the best way to further my understanding of cognitive science was through an applied approach. So, to begin, previous research suggests dance training contributes to higher cognitive and proprioceptive ability. However, this relationship has yet been thoroughly investigated as to what functions are involved and enhanced through dance training. For instance, it is possible that short-term memory, selective attention, multitasking, and proprioception, the sense of position and movement through the body and space, are involved. For this study, we first aimed to identify cognitive differences between dancers and non-dancers to inform theories of therapeutic intervention for both cognitively impaired and elderly populations. And second, to establish a real-world version of the neuropsychological assessment known as the trail-making test. We will recruit a total of 60 healthy adult participants from the University of North Texas and Dallas-Fort Worth Metroplex. Participants will complete an online questionnaire indicating their level of dance training, and we will compare behavioral performance between dancers and non-dancers. On the following measures, Phase 1 involves a digital trail-making test, a virtual adaptation of the gold standard neuropsychological measurement. This version of the traditional trail-making test is a step further from the pencil and paper version for administration, in which the same design is presented on a computer monitor and participants use a computer mouse to perform the task. This test consists of 2 parts, Part A and Part B. Part A requires the participant to select numbered targets in sequential order as they appear on a computer screen. Part B requires them to alternate between numbered and lettered targets in consecutive order. Both parts are to be completed as quickly and accurately as possible. During Phase 2, we will implement our development of a novel real-world version of the trail-making test known as the proprioceptive trail-making test. Similar to the digital test, this version uses the same design implemented in the traditional trail-making test. However, the proprioceptive test introduces walking as the primary method for identifying targets. And we increase the cognitive load involved in Part B by asking participants to alternate between their leading foot as they alternate between numbered and lettered targets. For example, when walking from a numbered target to a lettered target, the participant will only step forward with their right foot. That is, step right, step together, step right, and so on. When walking from a lettered target to a numbered target, they will only step forward with their left foot. Step together, left foot, step together, and so on. Whenever they do not step forward with the intended foot, or do not arrive at the correct target in the sequence, they will be asked to return to the original target they last left off at, and an error will be scored. Like the traditional trail-making test, number of errors and time to completion are used to measure the participant's performance. By asking the participant to return to the last correctly identified target when an error has been made, the time to completion is extended and indicates a degree in which errors were made. Additionally, when navigating through the proprioceptive test, there will not be a trail left behind to indicate the previously visited targets, where in the digital and traditional trail-making test, they are able to use the trail as a tool to identify targets, where in the proprioceptive test, they will rely on their own cognitive ability. We hypothesize that the digital and proprioceptive test will provide complementary results, indicating that they are both a valid measure for the same cognitive functions, and that the behavioral performance of dancers will exceed that of non-dancers through shorter completion times and less error on both the digital and proprioceptive tests. We propose that the results from these tests will provide a valid real-world measure of the traditional trail-making test, demonstrate dancers have a greater sense of spatial navigation, proprioception, and short-term memory ability, and contribute to dance-based therapeutic intervention by providing a viable option to measure and track progress. I look forward to sharing more as we progress. Thank you.